Dear followers, welcome to another video. And as we have several students who had their first class this weekend, I wanted to upload a beginner difficulty video. In this video, I will show how to connect to the Arduino, and we will do some one small project. I would still encourage all our younger students to do the project. And that being said, let's start. So before I jump to the code, I just want to announce that as my personal initiative, we are starting math classes in the second floor of the RMath building. If you're interested, this is our Instagram page and my phone number. You can also call or message me with RMath related questions. It's 818-858-4971. And that being said, let's start with the blank Arduino program. So you download the Arduino, you install it, and then the first time you open it, this is how it should look. And the gray means that these are comments, and it's only for you to look at later, or if you're sending the code to someone else, maybe you can write explanations there. We're going to delete it for now. And so the first thing you do, you make sure you're connected to the right board. The boards we use are Arduino Mega 2560. So it should say in the options. If you're operating, if your system is different and it might look, the top part might look differently. In the tools, there is Arduino board, which should be Arduino Mega or Mega 2560, and the port should be again Arduino Mega or 2560. And that being said, you should be able to compile and upload this empty code, after which nothing is happening on the board. And now let's start doing our very first project. And for that, I will take one LED. The longer node is the plus, the shorter node is the minus. I will connect the longer node to 13 and the shorter one to GND. After that, I will upload the following code to Arduino. First, we have to declare that something is connected from 13 and it's an output. And then I will write the code that turns 13 on. I verify, after which done compiling means there were no errors. Most common errors we see are colon instead of semicolon, parentheses opened, not closed, comma missing, brackets missing, etc. Now, after I upload it, 13 is on. So I want to bring your attention that the number we brought here is matching what we connected on the board. For example, if I tilt this LED a little and connected 12 GND, the longer to 12, shorter to GND, nothing is happening. But if I come back to the code and write 12 instead of 13, now 12 is on. So in Arduino environment, so in C++, writing time manipulations can be a little hard. But in Arduino, this is simplified. You just write the delay command. And let's write a code that will blink this LED instead of just constantly be on. So high means on, low means off. 500, it's measured in milliseconds. So 500 millisecond delay. It will blink every half a second. Every 0.5 seconds. Let's upload this. So the simple digital output, such as the LEDs, this is how we control them. Now let's learn how we control a sensor, how we measure something from the Arduino. I'm going to take this LED out. As the sensor, I decided to use probably the simplest sensor. So it comes in two parts. It's in the same box as the LEDs. And then it measures the rotations left and right. And to use this sensor, it has 3 nodes, 3 pins. So 2 of which are for power, 5 volt and GND. First, I'm gonna separate this piece and make sure it's all the way in. Sometimes if it doesn't work, 90% of the time, the sensor isn't in completely. And then from the same number, from the same line, I connect one of the pins to 5V, the other one to GND. Yeah, don't do it next to each other. It has to be, they have to be on the same line numbers. So the line numbers go like this. And 5V and GND, the sensor is on now. And for the measurement, I will measure the sensor from the other side, the other pin, the third pin. And the measurement will be connected to A0, analog 0. This is an analog sensor. Analog means it's changing gradually instead of on and off. So I can gradually increase and decrease it. And in the code, let's first write the measurement of the sensor. So first, I disconnected the LED, and now a sensor is connected from A0. Instead of output, it becomes input. So A0 is an input now. Next, I will write a command that allows to measure the sensor and display it on the monitor. It's the following: serial begin, and 9600 means it will measure 9600 times. So this is the default number. Please use this number for now. And so this is how the measurement will go. So it's an analog sensor. The measurement means read and measure from A0 and store it in a variable named value. And display the measurement on the serial monitor. Serial monitor, I'll open it in a second and show what it means. So show the value. Measure it, store it in value, and show the value. This is what the program will do. And first we verify that there are no mistakes and upload, done uploading. Serial monitor is this top right button. After I click it, and see now when I gradually rotate the knob, the measurements change from 0 to 1023. All the way left 0, all the way right 1023, somewhere in the middle 500. Now let's do one simple exercise. I will connect the LED from 13 again, longer to 13, shorter to GND. And I will write the blinking. So this knob controls the frequency of the blinking. And what do I mean by that? Like, for example, if it's all the way left, I want it to be faster. If it's all the way right, I want it to be slower. So first, we need to declare in the void setup that there is a output connected again. So 13 output. Here, I write a command to turn it on and off. So it will be digital write 13 high and 13 low. In between, I want to add a delay, but how much delay exactly? So if I just write value, the leftmost side will be 0, and 0 delay isn't something that's visible to a human eye. For that, I will just add extra 50 milliseconds. So the value plus 50 milliseconds, and I will write the same here. This means that when I rotate this knob, the values will go from 50 to 1073. And it will blink faster and slower. And here I made a mistake. Actually, it's good that this happened so you can see compilation error, semicolon missing. The computer even sometimes recommends what was wrong. That was the only mistake. Now I can upload it. See if it's all the way left. It's very fast. Let me open the serial monitor again. All the way left is very fast. A little more right is a little slower, and a little more slower. And all the way right will be slowest. It will be 1 second, roughly 1 second. And then again left, and again it's blinking very fast. So this is what I prepared for the first time. Many of our sensors are simple input and output sensors like this. We have other advanced electronics, and in another tutorial I will show how to use this. This is all for today, and thank you.